All right, in this video, we're going to cover some basic arithmetic and some basic algebra concepts to kind of get us started in the course. So kind of lay that foundation before we get into the algebra piece of it, right? So the first thing I want to talk about is what is a number. So, right, we have different categories of numbers. And I'm going to try to draw this in some circles here. So the first thing we have is what we call a natural number. Right, and sometimes these are called counting numbers. And they are the numbers 1, 2, 3, ... The reason they're called natural and counting is this is kind of how we all learn how to start counting. If we have siblings and stuff, you know, we typically start with 1, 2, 3 using our fingers and stuff like that when we first learn how to count. And they're natural. The next type of number that we have is what we call is a whole number, right? And all natural numbers are whole numbers, but it also includes the number 0. So 0, 1, 2, 3, ... So natural numbers are whole numbers, right? But not all whole numbers are natural numbers because 0 is the oddball out in this case, right? Then we have integers, right? And so natural numbers are integers, whole numbers are integers, right? So we have the numbers 0, 1, 2, and 3. But we also have the negatives, so -1, -2, -3. And the ... means they go on in that direction for infinity, right? So again, natural numbers are integers, whole numbers are integers, but not all integers are these because we also include the negative numbers. Then we have our last part of our circle, our rational. Okay, so still everything inside the circle. So every side, all those numbers we talk about are rational. And what makes something rational is it can be written in fraction form, A over B, where A and B are integers, and B cannot equal 0 because we can't divide by 0. So it means we have to put things into fraction form, right? Well, I can take a natural number, say 3, and if I put it over 1, it is still 3, but it also means it's in fraction form, so therefore it is a rational number as well. And then we have the oddball on the outside, which we will call, it is called this, an irrational number. All right, and irrational numbers are numbers that don't fit into any of those categories, right? So like pi, square root of 2, e exponent, and I can put them as fractions, right? Square root of 2 over pi, right? So it's not, they can't be written as fractions, it's just they are not integers. So if something is not an integer, then it is one of those other type of numbers. So let's talk about a few examples here, right? So we've already said, you know, 3 is a natural number, and if I put it over 1, it proves it's rational. But I could also have 0.23, which is a decimal, and I can make that into fraction form by putting 23, and then I had to move the decimal 1, 2 places, so 1, 0, 0. So I can make a decimal into a fraction. So that is also rational. So you gotta be careful. Repeating numbers are also rational, right? Because 0.3333, and I put a bar over means repeating, has a fraction that's associated to it, which is 1/3, which is still a is irrational. Now, this guy is only rational, right? Because it is a decimal. This guy is only rational because it is also a decimal. My 3 over 1 Well, he is a natural number. He's also a whole number. He's also an integer. And he is also rational. So the reason I like my little circle trick here is if I have a number, say, that's inside here, then it is all of these as I make my way outside the circle. So figure out where you start in the circle and make your way out. And that will help you tell the difference in these numbers. And the reason these are important is when we get further into algebra, we'll start learning about different types of expressions and functions, and they'll be limited based on what the number can be. And so we have to know what the differences is. I forgot to clarify here at the beginning, everything we're going to do in this class, these are all real numbers, no matter which circle you're in, irrational or rational, everything's a real number. We are not going to get into imaginary numbers. You'll get into that if you get into, when you take pre-calc, if you're going to go further on to the college algebra. So now let's look at a number line here. So we have our number line, right? And so if I make my little number, 9 zeros in the middle, we have 1, 2, 3, 4, and then -1, -2, -3, -4, right? And so there are all my integers. And we know if we're on the right of 0, my numbers are positive. And if we are going to the left of 0, these are negative, right? And we can put decimals on our form, right? So 1/2 is halfway between 0 and 1, so there's 1/2. I can have -3/2, which would be right here. So -3/2. So know where numbers fall on the number line is important, right? And again, if I want to put things as decimals, right? Say -3.6, -3.6. And again, I can turn that into a fraction. -3.6, I move the decimal one place. So that gives me -36 over, oh, not 100, over 10, so I'll move it one place. Right? Now, one thing we have to remember with our fractions, we must simplify, right? So these are both even numbers. All right, so when you simplify this, you can see that we get -18 over 5. And 5 is a prime number, so therefore, we know we cannot simplify anymore. So while we're on this point, let's talk about prime numbers. All right, and these are important because they allow you to know if you've finished simplifying or not, right? So our prime numbers, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, ... Goes on for a while. Notice 2 is the only even prime number because after you pass 2, 2 goes in everything. Because remember, what makes something a prime number? When something makes something a prime number is it is only factors are its number itself and 1. And since 2 can go into every single even number, then 2 is the only even prime number. And we'll get into this when we get into some prime factorization and these common multiples here in a little bit. So while we're on this is algebra. So we are going to deal a lot with variables. And the key with variables is all a variable is an unknown number or numbers, right? So the key with variables is we let a letter represent the number for now, right? And so the most common one that we'll see in algebra is X. But you can have Y, you can have Z, you can have all kinds, right? 26 letters in the English alphabet, you may pick any one you choose. Now, some are better than others. I wouldn't pick O, because O looks a lot like a 0, right? So some are better than others. So stick with the ones you like, but it doesn't always have to be X. And since X is the most common variable, then we got to remember when we multiply things, we really shouldn't use X no more. right? Because x is usually a variable in algebra, so we don't want to have x times x because then you have 3 x's, and then that becomes x cubed. So some other symbols for multiplication: a dot, a star, put in parentheses next to each other. And so those are the kind of common. This is the one you'll see me use the most. I'll put 2 parentheses next to each other, which means that we are multiplying. Now be careful when I write these things in my notes for you all to look at. That means multiply. Some calculators allow you to just put parentheses to multiply. Some of them you actually have to hit the multiplication symbol. So again, you got to kind of see which ones really work for your calculators. And you may use any calculator for this class. All right, so now let's talk properties, right? So, and why we need to know these properties is 1, they're part of the course, but 2, you understand them, algebra goes a little bit better, right? I'm not going to test you per se on the properties, but I can tell if you know them or not by how well you do some of the algebra applications we're going to do. So the first property we're going to talk about is the commutative property. And all that means is you can rearrange things, right? So we have a commutative property of addition. So a plus b equals b plus a. We just move the order, right? It is like you driving to the college and then you turn around and drive back home, right? You go in the same route, maybe, assuming you're just going straight home. And so you just swap directions. That's the commutative property, right? And we also have the commutative property of multiplication, which just again means I swap things. This is easy enough to show with numbers, right? So 2 plus 5 equals 5 plus 2. Well, 2 plus 5 is 7. 5 plus 2 is also 7. We just change the order. Same with multiplication. 2 times 5 is 5 times 2, which is 10 equals 10. The next property is the associative property, right? And this one deals with parentheses. And so the other one, I changed order. In the associative property, I changed the location of the parentheses. So a plus b plus c, I can put the parentheses around the first grouping, which equals a plus b plus c, and I put the parentheses around the last grouping. And again, there's one for multiplication, a, b, c, parentheses around the first, last, equals a, b, c, parentheses around the first. And again, if we put numbers to this, 2 plus 5 plus 3, put in parentheses, equals 2 plus 5 plus 3. And now my parentheses are at the end. So do us inside the parentheses first. 2 plus 5 is 7, plus 3 is 10. And then this one's 2 plus 5 plus 3 in parentheses is 8. Excuse me. And then 2 plus 8 is 10. And it works, right? Now, what I really like about this property is when you're all adding, I can actually just move the parentheses and I still get the same answer. So that's where I like to think of the associative property. I can move groupings around, or I can just drop them all together. So just like here, 2, 5 times 3 equals 2 times 5 times 3. And I'll change my parentheses placement. So there are some parentheses first. 5 times 3 is 15, times 2 is 30. 2 times 5 is 10, times 3 is 30. And again, if I drop my parentheses, I also get 30. The next property we will talk about is the distributive. Now this one is one we use a lot in algebra. So a, b plus c equals ab plus ac. And what you're doing is you're taking what's outside the parentheses and you're distributing to everything inside the parentheses. So I have 2, 5 plus 3 equals 2 times 5 plus 2 times 3. No, times 3, not 6 yet. So we do what's in parentheses. 5 plus 3 is 8, times 2 is 16. 2 times 5 is 10. 2 times 3 is 6. 10 plus 6 is also 16. Now in this case, does it really matter to distribute? No. But as we move further on in the course, then yes, there will be many times where this will help. And there's a lot of other rules that we already use a lot, right? The zero factor law, which just says anything times 0 is 0. So a times 0 is just 0. Then we have our inverses properties, where I have a plus a negative a equals 0. Basically, inverse means to cancel out here. So if I have 5 plus a negative 5, that equals 0. And there's one for multiplication. A plus 1 over a equals 1. So again, if I have 5, not plus, sorry, times. So if I have 5 times 1 over 5, that equals 5 over 5, which equals 1. And then finally, we have our identity, which means things don't change. A plus 0 equals a. 5 plus 0 equals 5. And then a times 1 equals a. 5 times 1 equals 5. So now let's talk our order of operations. All right, so the cool acronym that we like to use is PEMDAS. P-E-M-D-A. And you don't have to use PEMDAS. It's just a nice way to remember how to do these things. So PEMDAS stands for parentheses. I like to think of it as groupings instead, because there is more than just parentheses. There is parentheses, but there's also brackets. There's also absolute values, and there's also square root. And we're going to talk about these a little more detail in a minute. But you have to do what's inside of these first. That's why it's the first in the order of operations. Then we have our E for exponents. Right, which means, like if I have something like this, 2 to the third power just means 2 times 2 times 2. I take the base of 2 and I multiply it by itself by how many times the power is. So 2 times 2 times 2 is 8. Here is the tricky part with PEMDAS. We have to be careful. Multiplication and division, right? So we have multiply and divide. You do them first from left, whatever happens first, from left to right, just like we read. So just because multiplication comes first in the PEMDAS, it doesn't mean you have to do it first. You do whatever happens first between a multiplication or division. And we'll do an example here in a minute. Or, and same thing with add and subtract. You do whichever happens first. The reason for this is multiplication and division are basically the same thing. I can either multiply two numbers or I can divide two numbers. Well, dividing is the same as multiplying by fractions, so technically you're still multiplying. So they're very much the same thing. Add and subtract, same thing. I add the numbers or I subtract the numbers, right? Or I can just add a negative number. So let's look at an example here so that we can kind of see how this all works. So say we have 24 all over 3 plus a negative 5 equal, oh no, not equals, minus 4 times a negative 9 divided by a negative 3 squared. So, no parentheses here, right, that we can see. But what we have to be careful of is really you should put somewhere here. Because since it's a common denominator, I must do that first. So then I get 24 over 3 plus a negative 5 is a -2. Remember, minus 4 times a -9 divided by -3 squared. So now I'd have no parentheses. Now be careful, these parentheses here are just telling me to multiply. These parentheses here are just telling me that is all to the same exponent. So they're not really considered grouping. So my second step is to get rid of this exponent. And again, I'm doing this as one step at a time. You don't have to. I'm doing it so we can see the steps. So divide by -3 squared. And since the negatives in parentheses, we do include it, which gives this to be 9. So now I have 24/2 minus 4 times -9 divided by 9. So now 24/2 is a fraction that I have to simplify or divide if you want to look at it that way. So 24 divided by -2 is a -12 minus 4 times a -9 divided by 9. Now I have to do this. 4 times a -9, right? So I'll put equals here in -12 minus 4 times -9 is a -36. I'll put that in parentheses to remind me that there's 2 negatives. All right, and then divided by 9. So division is the next thing I do. So now I have -12 minus -36 divided by 9 is a -4. And now I can get to my final step, -12 minus a minus, which basically turns this whole thing into a big positive sign. So -12 plus 4 equals a -8. So kind of taking this in steps makes it a little bit easier to deal with. So let's talk about some of the other order of operations stuff here that we had for a minute ago, right? So we kind of went through groupings. Let's talk about the other groupings here. So we have an absolute value and a square root. So if I go to a number line, and I'll do -4, -3, -2, -1, 0, 1, 2, 3, 4. Not drawing a scale. You'll notice in this class, I rarely draw anything to scale. So if I take what I call the absolute value, which is 2 big lines with a number inside, most of you remember that that just means I make it positive. So the absolute value of -3 is 3. Or the absolute value of 3 is also 3. So a lot of us memorize it as, hey, I'm just making this thing positive. Now, what it really does, though, is it's telling you how far from 0 you are, right? So for the -3, I am located right here. Well, how far am I from 0? I am 1, 2, 3 steps away. The negative just tells me I am going to the left. But I'm gone to the left 3 steps. That's why it's positive. And then the same thing goes with a +3. I am 1, 2, 3 steps to the right, or I just know it's to the right. So the distance is always positive because I don't know how to go backwards in time yet. So therefore my distance always has to be positive. The signs only tell me which direction am I going. Am I going left or right? That's how absolute values work. And we'll get into later on, we'll actually solve algebraic equations of absolute values. Now, square roots, right? So say I have the square root of 9, that equals 3. And the reason for that is I can take the square root of 9 into 3 times 3, which still gives me 9, right? And because what there's a little 2 right here. We just don't write it because we're lazy mathematicians, but it is called a square root, so it is there. So I have to take the number inside and break it into 2 identical parts for something to be a square root. And so I can take 9 and do 3 times 3. So 1 kind of comes out, 1 goes away. That's how I like to remember it. Really, what you're doing is you're doing things backwards, because if you have 3 squared, not equals, I'll do a double arrow. 3 squared is 9. So these things are kind of like the inverses of each other, right? The square tells me that's 3 times 3. the square root tells me how to take 9 and break it back apart. And we can also do this with what we call a cube root. So that puts a little 3 there and say I have 27. Again, now I have to take 27 and I need to break it into 3 equal parts because I have a cube here. So the cube root of 27 is 3 times 3 times 3. I got 3 equal parts. 1 comes out, both come away, and this still equals 3. Now, what we have to be careful with here is when things aren't perfect squares. So let's erase this board here for a minute so we don't get ourselves confused. So we just did the cube root of 27, but what if I had the square root of 27? Well, I can't break the square root of 27 into two perfect numbers, right? But I can break it down to the square root of 9 times the square root of 3. And we just did the square root of 9, which was 3. I can't do anything in the square root of 3, so therefore that is my final answer. And we'll get more into this later on in the course. But I still want to make sure we have the foundation of how kind of square roots work. All right. So what else we will talk about today? Oh, let's talk about our good old friends, the prime numbers, right? So we went through primes and how we prime factor. So we have, say, 150. And basically, I like to build what I call a factor tree. So we can break this down. So take 2 numbers that go into 150. Well, 15 times 10 is 150. So I took 150 and I broke it to 15 and 10. Then I can break 15 down again and make that a 5 times 3. And 10, I can break that down to 2 times 5. And now I'm done because my branches all end with prime numbers. So the prime factor tree is 2 times 3 times 5 times 5, or I can rewrite it as 2 times 3 times 5 squared. Now, why this is important is, say I want to find the least common multiple, right? So least common multiple is when I look to do what is the smallest number a group of numbers going to. So a least common multiple, right, of a set of numbers. So say we have 27, 30, and 12. And if I'm asked to find the least common multiple, I'm asking, what is the smallest number that all 3 of these numbers can go into? Well, if I multiply them all together, that is a common multiple, but it's not the least common multiple. I need the smallest. So step 1, build your prime factor tree. So 27, 3 times 9, and then 3 and a 3. Again, I like to circle them because it reminds me that I'm done if every circle ends with a prime. Then 30, I can do 3 times 10, and then 2 times 5. Again, I will circle them so that I know I have finished because every tree ends in a prime. And then we finally have our 12. So 12 is 4 times 3, and then 2 times 2. Again, I will circle them because that shows I am. Step 2, write primes. So I have a 2, right there. I have multiple ones. I was going to run them once for now. I have a 3, so times a 3. And then I have a 5, and then times a 5. So I've written down all my prime numbers. Now, step 3, which I'm running out of room. I'll write it over here, step 3. So list the most a prime appears, sorry, horrible handwriting, in a set of numbers, right? So I had a student once, what she did is she would draw a little dashed line separating her trees to remind herself that I have to look at these individually. So I first start with the twos. I have no twos in the first group. I have 1, 2 in the second group, and I have 2 twos in the third group. Well, so the third group has 2 twos, so therefore I put a squared there. I don't count all of them. I count the one set that has the most. Then I go to threes. My first set has 3 threes. My second set has 1 3. My third set has 1 3. So the first set has the most 3. So I now have 3 cubed. And then there's only 1 5. I'm just going to put a 1 on there just so you can see where it came from. So we have 5 to the first power. So then I multiply these numbers together. 2 times 2 squared is 4. 3 squared is 27. And 5 to the first power is just 5. Now, I'm going to use the commutative property to help with my math, right? Because 4 times 5 is 20. So that gives me 20 times 27. And 20 times 27 is 540. So the smallest number that all 3 of those numbers go into is 540. So I think that's enough for this video. Covers the first couple sections of our course. And again, this is setting the foundation so that when we get into more of the advanced algebra, it will be a little bit better. All right, thank you for watching, and we'll have more videos.